All right, so this is a quick video on the solutions to the ACT April 2018 ACT questions that I asked you to look at. We'll start with number 1. So he gives you 2 points and he wants to know something about the slope if, which is a good idea, if you glance at the answers, you notice that there are no numerical answers. He just wants to know something in general about the slope. So I don't need to find a numerical answer. I need to just look at these points and see, well, where are they? Maybe I can answer his question. Since both x and y are negative, for the first point, that point's somewhere in the third quadrant. This point is somewhere in the first quadrant. If I connect the two, then I have a line that looks like that. And he wants to know, is the slope of that line positive, 0, negative, or undefined? Well, the slope of that line is positive. So you need to know then not just the slope formula, and the slope formula would tell you that too, but it would be more work. But you also need to just have a general understanding of slope. Lines that go this way have positive slopes. Lines that go this way have negative slopes. Lines that are horizontal, the slope is 0. And for vertical lines, the slope is undefined. All right, now, number 6. Number 6, he gives you an equation, and he wants to know the slope-intercept form of this line equation. Well, the slope-intercept form of any line is y equals mx plus b. So all we have to do then is take this equation and solve it for y. We want y by itself on one side of the equal sign. So the easiest way to get that for this line is to move the y. Add the y to both sides. And then I get 9x minus 5 equals y. And that's the slope-intercept form of that line. You can do it another way. It'll take a little bit longer. This was the easy way to do that. Now, for number 7, he gives you a line segment and he gives you a ratio. And we said that the best way to look at this ratio is really as a fraction. And so he's giving us that xy over yz is 5 over 9. Now, I might just want to write those two numbers up here on that picture that he gives me. Then he wants to know, well, what is xy to xz, but that's over xz. And xy over xz, well, xy on my picture now is 5, and xz is 14, 5 plus 9. So when xy is 5, then xz will be 14, just based on the numbers that he gives me. Okay, so for number 8, he gives us an inequality and just asks us to solve it, basically. The solution set is, okay? Solution set means we're solving, so I want to move my 4 over, and I get 2x is greater than or equal to negative 12. Then I want to divide by 2. X is greater than or equal to negative 6. You can use your calculator to help you do the adding and subtracting, multiplying and dividing, but that's the answer. Now when you look at number 9 is a simple exponent problem, but you do not want to have to write a to the third 21 times to figure out what your answer is. You just want to know the exponent rules. And when I'm raising something to a power, I multiply the exponents. So this is going to be a to the 3 times 21, which is a to the 63. Number 10 is a function problem. And remember that whatever is inside the parentheses for x is what goes in place of x. So for this problem, we put negative 3 in for x, and we leave it in parentheses. That's the safest thing to do. Negative 3 minus 8. Now you can just punch it into your calculator just like that, and it will assist you. This is not hard. We're just going to go ahead and do this by hand because we can. This is 27. This is going to be 29, negative 29. So I've got 27 minus 29, which is negative 2. Okay, so for number 11, he says we have a triangle. And he tells us that two sides are exactly the same. So he does not give me a picture. When he doesn't give me a picture, but it's a problem for which I can draw a picture, then that's what I'm going to do. So I draw my triangle and I label two sides exactly the same. I don't know what they are, so I call them X. But then he says that the third side is 3 centimeters longer than either of these. So I'm going to call the third side X plus 3. And then he gives me the perimeter. And we know the perimeter is adding up all the sides. So what I want to do then is to write that equation that I'm adding up all of the sides to equal the perimeter. So that's 3x plus 3 equals 93. And this is just a basic algebra. So you've got to be able to write this down, to write down an equation, and you've got to be able to work with it. I'm going to subtract 3 from both sides. So I get 3x equals 90. I'm going to divide by 3. So I get x equals 30. Now be careful to always go back and look at the question before you go marking answers, because the answer 30 is on this problem. But if I look at the question, he doesn't want to know the length of just any side. He wants to know the length of the longest side. And the longest side is this one right here. So the answer is going to be my 30 plus this 3, which is 33. All right, so number 13, he gives me a midpoint and one of my endpoints to a line segment. The midpoint is 3, -7. He wants to know what the other endpoint is. Now, let's just look at this real quickly and see if we can come up with an answer just by kind of looking at where these guys are. So the first point, 3, -7, well, that might be like right here. 9, -11 is going to be further down and further down this way. And so when I think about, since this is the midpoint, when I think about the other endpoint, he's going to have to be somewhere in this general vicinity right here. So I can look at my points then, and I can see, do I have a point in that general area? Well, the first point, -3, -25, no, that's out of the question. The second point, -3, 3, maybe. -3, -3. And then the third point, 3, +3, -2. Well, that's +3, -2. That's over here. No way that's going to be the answer. And point D, 3, 3, that's in the first quadrant. That's not going to be the answer. And then point E, 6, -9, that's not going to be the answer. So the only reasonable answer is the -3, -3. But let's say that your graph is bad and you can't really see that. What's another way to do the problem? So I look at the answers and I notice that there are 2 points with the same x and another 2 points with the same x. So that's not going to help me as much as finding y, because there are no points with the same y. So if I can find the y endpoint, then I can know what my answer is for sure. Well, remember that the midpoint coordinate equals the sum of the two end coordinates divided by 2. So I know my midpoint coordinate, it's -7. And I know one of my endpoints is -11 plus, here's my missing y. Now, if I just multiply both sides by 2, then this is -14 equals -11 plus y. And when I add 11 to both sides, then I have that y is -3. So sure enough, the point -3, -3 is the answer that I'm looking for. All right, number 17. The area in square decimeters of a right triangle with sides of 10, 26, and 24 decimeters. Now, he doesn't generally ask you to deal with units that are not compatible. And so in this problem, we can ignore the units. I do need to put these dimensions on my right triangle. He doesn't draw a picture, so I draw a picture. Make it fast. Don't spend time doing that. The largest side is always the hypotenuse, so the 26 goes here. And then I can put the 10 and the 24 right there. Doesn't really matter. He wants the area of that triangle. The area formula for a triangle is 1/2 base times height. The base and the height are always perpendicular. Base and height in any formula are always perpendicular. Well, here's my base, here's my height, or vice versa. they're perpendicular. The legs of a right triangle are the two perpendicular sides, so the area equals 1/2, 10, 24. I'm going to take half of the 24 and make that 12, and 12 times 10 is 120. Again, you can always use your calculator. So that's number 17, and then number 19, we have another right triangle, and he wants to know the sine of the smallest angle. In order to do this problem, I, again, need to draw the picture. He doesn't do that for me, and I need to label the sides. It's a 7, 24, 25 right triangle. The 25 is the largest side, so that's the hypotenuse. And the smallest angle, he wants to know the sine of the smallest angle. The smallest angle is always the angle opposite the smallest side. So this angle right here is opposite the smallest side. So we want to know the sine of theta. For this problem, you do have to remember your trig definitions. And so the sine definition is opposite over hypotenuse. So the sine of this angle is the opposite side, which is 7, over the hypotenuse, which is 25, and that's the sine of the smallest angle. And then the last problem in this video is number 20. We have a figure given like that. He wants to know the area of the figure. Well, the easiest way to do the area, you can do it lots of ways, but the easiest way is to get the area of the entire thing and then subtract the area of this green. So the area of the whole thing is just 10 times 12. That's the area of the entire rectangle. This dimension right here, since the entire width is 10, and this much is 3, this is 7, and then the length is 12, and since this much of the length is 5, this has to be 7. So really, I just want to take the whole thing, 10 times 12, and subtract 49, which is my 7 times 7. So that's 120 minus 49. Now, again, you can use your calculator. This is going to be 120 minus 50 is 70, but I really only want to subtract 49, so I get 71. So the answer is 71.